Welcome to the channel. The purpose is to facilitate students in learning physics at their convenience. Students, it is a class without a classroom, so learn physics at your convenience. Let us start our today's lesson. The topic is circular motion. Students, what is circular motion? A type of motion in which a body moves about a fixed point such that during the motion its distance from fixed point remains same. Such a motion is called circular motion. Students, for example, a stone tied with a string and whirled around in a circular path is the example of circular motion. We will define the terms that we have already discussed for linear motion here again. For example, angular displacement, angular velocity, and angular acceleration. We will discuss these three terms in detail for circular motion. Let us start from first, that is angular displacement. Students, look at this diagram. If a body is moving in a circular path, at some time it is at point A such that OA is its position vector from the center of the circle, and after some time it is at point B such that OB is its new position vector. Now the angle between these two position vectors is called angular displacement. It is denoted by theta. Students, AB is the arc and OA or OB represents the radius of the circle. Now the angle between OA and OB is called, as I told you, angular displacement, and it is denoted by theta. Students, mathematically, again look at this diagram. Since this theta is proportional to the length of the arc, longer the arc, more will be the angle, or more will be the angular displacement. So we can write S is proportional to theta, or S equals to r theta. When we remove sign of proportionality, we insert a constant, and here r, the radius of the circle, is constant. As I told you, when a body moves about a fixed point such that its distance from the center remains constant, so r is constant, so we get the equation S is equals to r theta, or rearranging this equation, angular displacement theta is the ratio of S over r. S is the arc and r is the radius of the circle. Now students, when S is equal to r, means length of the arc is equal to the radius of the circle, then value of this angular displacement is 1 radian. We say that the unit for measuring angular displacement is radian. SI units for measuring angular displacement is radian. And for a complete circle, when a body starting from A completes one rotation, then the total length of the arc is equal to circumference of that circle. So we can write S equals to 2 pi r. Inserting this value of S here, we get theta equals to 2 pi r over r. R will be cancelled with r, and theta equals to 2 pi radian. For a complete circle, the value of angular displacement in radians is 2 pi. What is its relation with other units? For complete circle, 2 pi radian is the angular displacement, and for complete circle, 360 degree is the angular displacement. So we can write 2 pi radian equals to 360 for one revolution, or 1 radian equals to, taking 2 pi on the other side, 360 divided by 2 pi, which is equal to 57.3 degree. So we can use radian as well as degree as a unit for angular displacement. Students, angular displacement is a vector quantity and its direction will be perpendicular to the plane on which the body is rotating. For this purpose, we will put our right hand such that fingers of the right hand curl in the direction of rotation, then thumb points the direction of angular displacement. So this is all about angular displacement. Next is angular velocity. First of all, we will come to its definition. As you have defined linear velocity as a rate of change of linear displacement, so angular velocity is defined as the rate of change of angular displacement. It is denoted by omega, and mathematically omega equals to delta theta over delta t. Delta theta is what? Change in the angular displacement, and delta t is the time taken for that change. Students, angular velocity is also a vector quantity. Again, its direction is perpendicular to the plane of rotation of the body. If a body is rotating in anti-clockwise direction in a circle of radius OA or OB from A towards B, then by right hand rule omega is directed upward along the axis of rotation of the body. It is a vector quantity. Its unit is radian per second. Next is angular acceleration. By the definition, rate of change of angular velocity is called angular acceleration. Mathematically, it is represented by alpha. Alpha equals to delta omega over delta t. What is delta omega? Change in angular velocity, and delta t is the time taken for that change. Its unit is radian per second square. Look at this diagram again. If a body is rotating in anti-clockwise direction and its acceleration is positive, means its speed of rotation is increasing, then alpha and omega, angular acceleration and angular velocity, will in parallel to each other, will be in the same direction. On the other hand, if body is rotating anti-clockwise but its speed is decreasing, then alpha and omega will be directed opposite, then alpha will be directed downward. So positive acceleration, angular acceleration, will be in the direction of angular velocity, and negative angular acceleration will be opposite to the direction of angular velocity. So these are the terms that we use in case of circular motion. I hope it is clear, students. Thank you for sparing your time to watch the video. If you liked it, don't forget to subscribe the channel. Take care of you. Thank you. Goodbye.